So the trig ratios. And of course, as you know, it's all based around the right-angled triangle. That's how we first introduced trig. And we learned that the longest side was called the hypotenuse. And then we learned Pythagoras' theorem and got really excited. And then along came trig. So if we identify one of the angles, I've identified the top one there, then we can name the other two sides, and we come up with very creative names. The side opposite the angle we call opposite, and the side next to the angle we call adjacent. But that then allows us our trig, our first three trig ratios. Now, I just mention this just in case. Remember, the ratios are not sin, cos and tan. They are three-letter abbreviations. It's sine, cosine and tangent. Okay? The only reason I mentioned that is because it's a long time ago now, but I do remember a test once, might have even been a junior test to be honest, and the question was find the sine of 60 degrees, and the person left it blank because sine, what's sine? They knew how to find the sin. 60 degrees, not the sine. So they are, of course, our abbreviations. So sine, opposite over hypotenuse, cos, adjacent over hypotenuse, tan, opposite over adjacent, all sorts of creative ways of remembering those ratios. However you choose to do it, of course, is up to you. But then we introduced the reciprocal ratios. And I always think they're not logical. Because to me it would be logical for cosec to be the reciprocal of cos and sine. But no, they just try and trick us. So cosec, of course, is actually the reciprocal of sine, and sec is the reciprocal of cosine. Cotan and tan, that's got a logical connection there. But they are three reciprocal ratios. And the reason we have the reciprocal ratios is actually because of inverse trig. You might think, what? Because the symbol for inverse functions, you remember, is the -1 symbol. And so when we write the inverse sine, we write sine and then the -1 theta. But the other thing we do with trig is when we're doing powers, we write the power in that same position. So -1, am I talking about the power of -1 or am I talking about the inverse function? And so for that reason, we never have trig to a negative power. We use the reciprocal ratios, and then there's no confusion. Now, I don't know whether that was explained to you or not when you saw these ratios, but that is why. That is why we have the reciprocal ratios. Sine x is equal to the cosine of 25 degrees. Well, assuming we're talking about a right angle triangle, of course, so x has to be acute, then x therefore must be... And why? Right, because the co in front of cosine, in front of cosec, in front of cotan represents complementary. That's what it's actually standing for. So we know the two angles are complementary. So 90 minus 25, well, okay, it's got to be 65. So using that idea, if I've got cotan of x minus 20 is the tan of x plus 30, again, we're assuming acute angles for this. Well, I know these two must add up together to give 90. And thus we get x equals 40. But that's basically the language of the abbreviation. So the prefix co means the complementary ratio. Basically, there are three types of standard right-angle triangle trig questions. Two of them involve finding the side. One where the side is not the hypotenuse. So we go, which ratio is A over 13? Or opposite over adjacent. So okay, that's the tangent of 61. We rearrange it. 13 times 10, 61. Press some buttons on our calculator and hopefully get the right answer, 23.5. The second one where we're finding a side where it is the hypotenuse. Now I could go x over 5 and use a reciprocal ratio, but unfortunately our calculators don't have the reciprocal ratio button, so it's usually easier to stick with one of the three main ones. So 5 over x is the sine of 32. So this time x will be 5 divided by sine of 32. And I always think, well, the easiest way of remembering it is, if the pronumeral's on top, I'm going to end up multiplying by the trig. If the pronumeral's on the bottom, I end up dividing by the trig. But anyway, it's a fairly simple equation to solve. We've got 5 divided by sine 32, there we go, 9.4. The third type, of course, is when we have to find an angle. So again, we identify it's the cosine ratio. That's what I was talking about with the inverse function. So we've got to find the inverse cos of 10 on 14. And I've done mine to the nearest minute, 44 degrees, 25. So they are the first 3 basic types of trig questions. And then we said, okay, well there's certain ratios where we want to know the exact values. They come up a lot in questions, and so we have them. And how they are created, I've got a equilateral triangle there, all sides being 2 in length. And so all angles are 60 degrees. If I chop it in half, I get a 30-60 triangle. And from there I can read off the exact ratios. Got to work out the third side, of course. It turns out to be the square root of 3. So now I can just read it off and go, oh yes, look, sine of 30 is a half, cos of 30, root 3 on 2, tan of 31 on root 3. And then I can do the 60 ones as well. And we notice the complementary ratios, 30 and 60. Oh look, we've got the same answer. Cos of 30 is the same as sine of 60 and so on. So there's our 30-60. To get our 45, we have the standard right-angled isosceles triangle. So both angles are 45. We'll make the side length 1. Root 2 then becomes the hypotenuse. And we complete our set there. So sine 45, cosine 45, and tan 45. Now, I don't know how you remember them. I personally, I guess, have always just remembered the triangles myself. If I ever forget, I go, There is another way of remembering. There is a neat little pattern, which, listening to some people earlier, no one's ever shown you this pattern before. But have a look at what happens. If I draw up a little table of values like this and go across 0, 30, 45, 60 and 90. So I've got the exact values, but the 2 boundary values as well. There's the sine ratio. Square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. So it actually is a nice little progression there. And then cosine reads the other way, of course. It starts as the square root of 4 over 2 and goes down. And tan, well, if you remember, tan is sine divided by cos. So the denominators are the same. I just got to go the sine over the cos. So I get root 0 over root 4, root 1 over root 3, root 2 over root 2, root 3 over root 1, and root 4 over root 0. So it's just a little table of values, and again it comes up with the exact ratios in a nice pattern. Isn't it wonderful how patterns just pop out in mass in the most unexpected places? Measuring angles then. How do we do it? We talk about things called angles of elevation. So the definition of an angle of elevation, the word is the clue. Elevate. So we elevate from the horizontal. And the correct way of naming this angle, it would be that it's the angle of elevation of B from A. So it's of what I'm looking at, if you like, from where I'm standing or where I'm observing. So of B from A. We have an angle of depression as well, and that's where we depress or lower. And let's put that one in. And that would be the angle of depression of X from Y. Now, the angle of depression is always equal to the angle of elevation. Always. Because if you look at it, imagine combining those 2 pictures together, you've got the classic alternate angles from geometry. So I don't know about you, but you know the classic cliff question, where, got a cliff that's 100 metres high, and there's a boat, and we're looking at the boat, and they tell me the angle of depression. I always go, angle of depression, but I'll label the angle of elevation because I've got a nice neat triangle. Then we have the compass bearings. Of course, we have NEWS, make up the main compass points, hence the word news, because that's information from all round the globe or all round the compass. That's where the word comes from. No, I'm lying to you, it's not where the word comes from. But it's a good story, isn't it? Now, then we then break up our compass bearings into equal amounts. So if I bisect that And then we say northeast. We always go with north or south. So we start with the, what should we call them? The vertical ones rather than the horizontal ones. So it's northeast, not east-north, it's southeast and so on. But of course we can divide again. And in this case we start with the more important of it. If you think of levels, so the blue level would be higher than the red level because we got the red one from dividing the two blue ones. So I'll start with the blue one, and that would be north northeast, and then that one would go east northeast. And theoretically I could keep going. I mean, if I was to now go halfway between the red one here and the green one, I'd start with the higher level, which would be the northeast. And so halfway between northeast and north-northeast, I'd call northeast, north-northeast. But of course, after a while, it starts to get very confusing. So we don't usually go past the north-northeast, east-northeast, and so on. Once we get past there, we start to use what we call true bearings. And true bearings are where you start from north, and it's just how many degrees you've gone round clockwise. There's 2 points, x and y. I could say the bearing of y from x. So I'm looking at y, I'm standing at x. I always draw the compass in where I'm standing. That makes life easier, I think. I'm told that's 30 degrees. So the bearing then would be 120. Start at north, go around. Now, some people like to put a T after it to say, hey, this is a true bearing. And yeah, I don't know that you really have to do that, but it is normal to use 3 digits. So if it was only, say, I don't know, 22 degrees, you would write 022. So that is a standard sort of thing. So that's bearing of y from x. Of course, if I did it as a compass bearing, it would be south 60 degrees east. And if I'm looking the other way, of x from y, now I'll put the compass at y, and it would be 300 degrees. Start at north, go around clockwise. And as a compass bearing, north to 60 degrees west. So that's all the sort of language that we see in those classic trig problems. So we need to interpret. We keep our fingers crossed, of course, that they supply us with a diagram, because then that's sometimes a bit easier to look at the picture rather than try and interpret the words. Sometimes they don't give us the diagram, sometimes we got to interpret it and hopefully draw up a correct one. Alright, yeah, picks up. Look, I think if from memory 1 to 3 is just, do you know how to use your calculator? So, I mean, if you're comfortable using your calculator, that's fine.